Hello everyone, welcome to DrZ Academy. In today's video, we're going to move on to section 3 of chapter 2, counting method, the permutations and combinations with indistinguishable objects. Let's consider this theorem first. The number of different permutations of n objects of which n1 objects are indistinguishable and of type 1, and 2 objects are indistinguishable and of type 2, and so on, and R objects are indistinguishable and of type R, let's say. Okay, so in this case, the number of different permutations is the following notation. It is, all right, so this one equals what? The ratio, right? So on the top is n factorial. Over the bottom is n1 factorial times n2 factorial, times nr factorial. Here, n1 plus n2 plus nr equals n. Okay, so that's the number of permutations, right? So of n objects, some of them are of type 1 and of type 2, right? So they're indistinguishable. Okay, so in this case, the number of permutations is going to be given here. Now let's consider example here. Okay, so how many different permutations can be made from the letters in the word infinity? Okay, so now let's consider how to solve this question, right? Solution. How many letters? There are in total n equals 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters in the word infinity. Okay, so now there are some words are indistinguishable. They're all exactly the same, right? So of which how many I's? 1, 2, 3. 3 are 3 letters of I, right? And how many N's? 1, 2. 2 letters are, okay, so just rewrite this one. 2 letters are in, okay? And 1 F, 1 letter is F, 1 letter is T, and lastly, 1 letter is Y. Okay, so here we have 3 letters are I, 2 letters are N, 1 letter is F, 1 letter is T, 1 letter is Y. Okay, so how many in total? 3, 5, 6, 7, 8 in total, right? So that's very good. So we know that here is N1, all right, and this is our N2, and N3, N4, N5. There are 5 different letters, right? 5 different letters. So hence, due to that theorem, we have how many? All right, so in total that's 8. We have 3, 2, 1, 1, 1. Okay, which equals what? All right, so 8 factorial, 3 factorial, times 2 factorial, times 1 factorial, 1 factorial, 1 factorial. Now you can use the calculator to find this value, right? So now here again, using this calculator here, right? So let's just do that. We have 8 factorial, 8 prob, and 3 factorial. Okay, so 8 factorial is 40320. Okay, and then you see 3 factorial is 6, 2 factorial is 2, right? 2 by 6, that is 12. All these ones are ones, right? So now just use this one divided by 12, right? So you got what? This one equals 3360. Okay, this equals 3360. All right, so that's the number of different permutations for this one. Now, let's consider another one, right? So how many ways can you put 3 red, 2 black, and 5 blue chairs in a rule, all right, in a rule? So solution. So we assume that these are 3 red ones, they're going to be exactly the same, black, exactly the same, 5 blue chairs, only the color are different. Okay, so solution. There are in total 3 plus 2, 10 chairs. Right? So 3 of them, based on that, the n equals 10, and 1 is 3, and 2 is 2, and 3 is 5. So we have what, 10, 3, 2, 5. All right, so equals 10 factorial, 3 factorial, times 2 factorial, times 5 factorial. So let's consider what is 10 factorial again, right? So 10 prob, go to factorial. All right, so equals, all right, write down here. Oh, it's a large number here. So 3, 6, 2, 8, 8, 0, 0. All right, 3 factorial, that's 6. 6 times 2, that's 12, times 5 factorial. Okay, so 5 prob. Okay, so it is 1,440, now which equals, right? So 3, 6, 2, 8, 8, 0 over 1,440. Okay, so I found this one is 2, 5, 2, 0. Okay, so that's the number of different ways you can put these chairs in a row. Very good, thank you. Good. Now let's consider so-called partitions. All right, so we want to partition or divide a group into objects into subgroups. Okay, so now let's consider this as partition problems. Assume there are n distinct objects to be partitioned into k, right, different groups, so that there are n1 objects in group 1, n2 objects in group 2, and nk in group k. So where n1 plus n2 plus nk equals n. Now, how many ways different partitions are there, right? So this is the type of question about partition, right? So partition. Now, again, for this type of question, we consider the following theorem: the number of different partitions of undistinct objects into k different groups, so that, all right, so is, all right, is what? This one, all right? So which is very similar to the permutation problem of the previous theorem, right? So let's consider this one, right? So consider example here. In a scientific conference, there are 19 talks to be assigned to 3 different sessions: morning session, afternoon session, and evening sessions. And how many different assignments are there, right? So you have 19 ones, you put them assignments, right? So here if they're morning session, they're in the morning session, right? So we are just put these ones 5 in morning session. We don't care about order within this morning session, okay? So this is the question, okay? So because it's a partition, all right? So now let's consider this one, solution. Now there are how many? This is a partition problem. With, all right, n is 19, and 1 is 5, and 2 is 8, and n3 is 6. Hence, there are 19, 5, 8, and 6, right? So equals 19 factorial, 5 factorial, 8 factorial, 6 factorial equals, all right, so you can find this one. Okay, so, well, 19 factorial can be a really large number, right? So, okay, 19 factorial over 5 factorial in the parentheses. Okay, 5 factorial times 8 factorial times 6 factorial, close the parentheses. All right, so this is a large number here. So I just directly found it. Okay, so here is, right, so equals what? 3, 4, 9, 1, 8, 8, 8, and 4. Okay, so that's the number of ways. All right, so I consider another example. A total of 9 kitties are to be divided into 3 groups of equal sizes. How many partitions are there, right? So again, partitions, in total that's 9, and 3 equal sizes, 3 groups of equal sizes. So N1 equals N2 equals N3 equals 3. Now total is N equals N, right? So therefore there's 9, 3, 3, 3, right? So equals 9 factorial over 3 factorial, 3 factorial, 3 factorial, so equals, now again, using this calculator, right? So 9 factorial, all right, so over parentheses, 3 factorial times 3 factorial times 3 factorial, close the parentheses, all right, so it is 1680. All right, 1680. Easy, right? So very good. Now, the last situation, right? The partitions of indistinguishable objects. All right, indistinguishable objects. Now, in these ones, the objects are different. Okay, so but now we are going to talk about partitions of indistinguishable objects. Okay, so assume there are n indistinguishable objects. We are to divide them into k groups. How many different ways are there? Okay, so here is a theorem. All right, so the number of different partitions of indistinguishable objects into k different groups is actually this one. All right, actually this one. N plus k minus 1, choose k minus 1 equals this one. All right, equals this one. All right, just this is the partitions of indistinguishable objects. All right, so you have a lot of ones and then to separate them. And for the reason why it equals this one, you may consider some Google it. All right, so but I'm going to here in this video, I'm just listing this result. Now, if these objects are indistinguishable, and then the number of partitions, all right, into k groups is going to be this one. Now, how many ways can we distribute 9 identical balls into 4 different boxes? All right, so identical balls, right? 4 different groups, 4 what? Boxes, right? So therefore, here n equals what? 9. Here k equals 4. So there are what? All right, so you can just put in here n plus k minus 1, choose k minus 1. It's going to be 9 plus 4 minus 1 over 4 minus 1, which is, all right, so on the top is 12. All right, on the bottom is 3. Right, 12 choose 3. So now you can use the calculator, right? So 12 prop, choose 3, and you find 220. All right, so 220. All right, 220. Okay. Now consider another example. How many different solutions to this equation if xi are non-negative integers, right? Non-negative integers. Now this can be viewed as what? You have in total 20 identical balls, like 20 ones, right? So, and then you're going to distribute them into 5. Sorry, this is 5, right? 5. I is 1 through 5. 5 boxes, right? So 5 boxes. Now, how many different ways are there, right? So in each box, if it is 0, it can be 0. If there are 2 balls, then xi is 2, right? So it is similar like this one, this problem, partition problem of indistinguishable objects, right? So similar like this one, right? How many ways can I distribute a 9 identity balls into 4 different boxes? So you can view it as what? You have 20 identical balls, and you are going to distribute it into 5 boxes, right? So some of them may be a 0, some of them may be 1, all right? So, and so, but the total is 20, yes? So now, and all these integers, what, ones, the balls are identical. So here you can have n is 20, k is what, 5, right? So here is going to be n plus k minus 1 choose a minus 1. So which is 20 plus 5 minus 1 and 5 minus 1. All right, so which equals what? 24 choose 4. All right, so now you can find this one using the calculator again. All right, it's 24 prob choose 4. Okay, so it is 10626. All right, 10626. Very good. Okay. All right, so that's about this section, and I will see you in the next one. All right, please leave a like, and I will really appreciate it. And thank you very much. Bye-bye.